Quantum mechanics is different, but so far it isn't too weird.
Okay, Jeeves, show us a little weird. Where is the weird?
Where's the weird, you ask? Once you get past existence coming and going, and virtual particles, and uncertainty, and exclusion, most of the weird stuff in quantum physics comes from what is known as entanglement, and subsequently wave function collapse. When two or more particles interact, their wave function becomes entangled in such a way that some properties of each are now depending on what happens to the other particle. Then these particles can be carefully separated, while in careful isolation to distant locations. But as long as they're not disturbed, they are still entangled and still have properties dependent on each other. Then, when one particle is examined to see what the individual property might be, the wave function instantly disentangles. Physicists would say this wave function collapses. Instantly, the other particle has its codependent properties disentangled and determined. Here is an example. We can set up a source to emit electrons in pairs, with their spins dependent on and opposite from one another. Now, neither electron knows what spin state it is in. Both are flip-flopping back and forth between spin up and spin down. But their wave functions are entangled, so that whenever one of the electrons is disturbed and settles into one of the spin states, say spin up, the other electron instantly settles into spin down state. And this instantly occurring collapse happens whether the electrons are next to each other or on the opposite side of the planet. And while some of that is truly weird, a host of modern technologies are beginning to rely heavily on this weirdness. Quantum computing, quantum cryptography, and quantum teleportation, to name a few. And because of the work they are doing in these fields and others, many scientists have little doubt that this particular quantum weirdness is an actual phenomenon. Real entanglement experiments have now been done where the separations have been over 100 kilometers, proving that distance does not destroy entanglement. This is analog. This is digital. This is analog. This is digital. This is analog. This is digital. If it is continuous, it is analog. If it is granular, it is digital. The current trend in audio, video, and communication technologies is to go digital. Instead of a continuum of color in video devices, we are limited to some finite number of colors. Instead of a continuous picture, our photo is divided into pixels. Instead of just any frequency in audio, we are limited to specific steps. This is very much like the universe in the realm of the small. The entire universe went digital about 14 billion years before we thought of it. Space, time, energy, momentum are all granular. There are only certain specific values allowed, and this granularity is accurately described by quantum mechanics.